Hi everyone, welcome to Mr. Carlson's lab and welcome to the restoration process of this RCA CR-88 radio communications receiver from the 1940s. This particular radio communications receiver was used at government listening posts way back when. Those secret government listening posts that you've never heard of and that you will never know of. This one here was definitely used in a very quiet environment, and I'll tell you how I know that. Each one of these radio communications receivers tells a story. So basically they read like a book. You can see what's been done to them throughout time. You can tell what people have been thinking when they modified them, and even what the engineers were thinking when they put these things together. And that even goes right back to when it was in service. Again, I'll show you how to do that throughout this entire restoration episode. Now, the whole idea is to make this radio receiver perform the way it did when it rolled off the factory line. Then what we're going to do is compare this to other radio communications receivers and see how well this thing performs. Now, I can tell you this already. These radio communications receivers did not fool around. These things are nothing short of fantastic radio communications receivers, even to today's standards. So, you'll be able to see the entire restoration process, and you'll also be able to see how well this thing performs when it's all restored, and that should be a lot of fun. So if you haven't subscribed to the channel, you're going to want to do that now, and don't forget to tap the bell symbol so you get notified when I put up the new videos about this particular radio receiver. So today what we're going to do is we're going to take a look inside. Now, I know as much about this thing as you do. I haven't opened this thing up aside from lifting the top lid and moving the dials around and things like that. So I don't know what's on the underside. So this thing might be totally butchered up. If it is, not a big deal. We'll make this thing back to stock again. If it hasn't been butchered up, even better. It just makes the process go just a little bit quicker. If anything rolls, I guess if we encounter anything or rolls into our way throughout this entire restoration process, that's a bit of a roadblock. We'll work our way through it, and we're going to get to the finished product here. So today, we'll take a look inside, and what we're going to do is we're going to turn this thing on. I'll bring it up slowly, and we'll see if it even receives just the way it's sitting right now. It looks like all the tubes are inside. I'll show you inside here in just a moment. It looks like all the tubes are in there and everything. So maybe it'll even work just a little bit. That'll give us how it works now to how it is going to work when it is completely restored. So this should be a lot of fun. So it should be a fun journey together. And there's a lot more of these things coming too. So I've got lots of communications receivers. And down the road, we'll just compare all sorts of different communications receivers one to another. So it'll give you an idea if you want to, say, restore one of these things, the ones to actually restore and the ones that really perform well. And again, I can tell you, this thing is nothing short of fantastic. So anyways, what we'll do is I'll move the camera, we'll take a look inside this thing, and then I'll flip it onto its side would be the easiest. So the thing is equally as heavy. This thing is, I can't tell you, this thing is incredibly heavy. Incredibly heavy radio receiver, as heavy as some transmitters. So lots of iron in this thing. Anyways, I'll show you some hints and tips about moving this thing around on your bench so that you don't destroy your bench with it and all sorts of good stuff. This is crammed with information. So let's get started. Let's take a look at the top side of the chassis. Now, to get at the chassis, it's very easy. Remember, if this thing fails, it needs to be put back into service ASAP, and I mean quickly. So when the RCA engineers designed this case, they designed the lid with an opening that's almost the entire size of the case, so you can very quickly get to the vacuum tubes. So to get inside here, all you do is you hook your finger, put it in this little hole here, and give it a tug, just like so, and you're inside. See the latches here? And just like that, we're at all the vacuum tubes inside this radio receiver. You can see all the metal tubes here, some of the glass tubes. There's more vacuum tubes under here. Whether they're there, I have no idea. Again, at this point, this is as far as I've gone with this radio receiver as I've looked in the lid. So we're at the same point right now. Now, another funny thing is if you get one of these things, it says alignment tools inside this cover. Good luck with that. I'd say 90, maybe 95% of the time when I've restored these radio receivers in the past, those tools are always missing. Sometimes even the tubes are missing on the underside, which is a real pain as well. Now, there's a dead giveaway right now that this has already been tampered with. Can you spot what that is? All right, well, you can see finger screws here that hold this case down. So you remove this one and then the other ones, and then this whole case comes off so you can very quickly get at the tubes. Well, we have a finger screw here, one over here, and oh look, irregular screw. Somebody's lost a finger screw. So that already tells us that somebody's been under here. So hopefully all the tubes are in there. We'll find out. Now here's a trick for you. If you purchase one of these radio receivers and you're concerned about the power transformer, obviously one of the most expensive parts in here, being bad, one very quick and easy way to test this to get a very good idea whether it's okay is take the rectifier tube, which is this tube right here. Take the rectifier tube, just take it out. And then you can bring up the AC line, if the AC line cord is okay, and of course, you know, if you figure through your experience that it's okay to plug this in, remember you're doing that at your own risk, but if you figure that it's okay to plug in, if you turn the thing on and all the dial lights come up and the transformer doesn't get hot or anything like that, there's a very good chance that it's going to be okay and the secondary high voltage windings or the B+ windings inside this transformer are going to be just fine. Now, if there's a short in the secondary B+ windings inside this, now the B+ windings feed the plates of this directly heated rectifier right here. If there is a short in those windings, this is going to draw heavy current. So just make sure that you have a suitable fuse or some form of current limiting in line with this radio receiver. And if that fuse was to go, but it was trying to light up, you would know that, you know, probably this has been powered up with a shorted filter capacitor, or maybe one of the smaller capacitors on the underside of the chassis has a short in it, and it's caused this to go away either through red plating this or a shorted rectifier. Now I have to tell you, it's extremely rare that these power transformers ever fail. This isn't like a consumer grade power transformer. Again, these things were designed for very special service, and this thing was designed to take a beating before anything would go wrong with this thing. So very, very good chance that it's going to be okay. So we have the power transformer here, filter capacitor here, filter reactors right here, and an audio transformer, and on the underside there's a whole bunch of other small capacitors, decoupling and things like that on the underside, and I'll show you all of that. So this is also very valid for testing other types of communications receivers and amplifiers as well. Take the B+ rectifier out, and it'll give you an idea if the power transformer is okay, if you're concerned about that. A little trick to put in your book right there. Now this here is a regulator tube, and these normally glow either a purple, kind of a purpley blue color, or an orange color. So if you see them glowing that purpley blue, don't worry, it's not gassy, it's supposed to do that. Sometimes they glow orange as well, so either or, just depending on the gas that they're using in that particular type of rectifier at the time. So that's the top side of the chassis. So what I'll do now is I'm going to flip this thing onto its side, and we're going to take a look at the underside. There's a service panel on the bottom we'll remove, and we'll take a look inside, and that's where the real truth is. Has somebody been in this thing and butchered it up or not? Well, we're going to find out. So I'll reposition the camera here, and I'll show you how to safely move this on your bench without completely destroying your bench. I normally take these little felts, as you can see here. You got a sticky side on the back, and what I do is I put them on the underside of the feet on the bottom of this thing, and it allows me to move this thing around on the bench really quite easily, right? Without damaging anything. So you can kind of see one of them here underneath the feet on the back side there. So that allows me to move this around on the bench without scratching it up. Now if I want to tilt this on the side, that is a completely different situation. So you can usually find these at your local dollar store. So in the arts section, it's a nice little, I guess you could say, paper coated piece of stiff foam. And usually what I do is I use this for many receivers. So you put this underneath because you don't want the edge to hit the bench. Okay, so you put this on the underside just so it's touching the feet just like that. And then I might need to get in front of the camera here so you can see this. So I'm going to grab this and tilt it up so that this tilts onto this thing here, and then I can move this around, okay? So move that up like so. Just like that. And then that way I can slide this around as well. Now, you can see it wants to come off of that. And that way you don't destroy your bench top. Now, you can see there's screws on the bottom of this thing. Let's see if I'll move this up just a little bit here. You can see there's screws on the bottom of this thing here. So if you drag one of these on your bench top, this thing is so heavy that it's just gonna put it'll carve a line in your bench. So you gotta make sure that you don't do that. You can see the little felts here that make this very easy to slide around. Now, of course, if you put these things on, make sure your bench top is clean. If you have a nice bench top like this, if you get a piece of solder or something like that in this and you slide it around, well, you obviously know the results of that, right? It's gonna put a big gouge in there as well. So just make sure your bench top is clean. So now what I'm gonna do is just remove all of these screws. I can see one here, looks like it's been broken off already. So obviously this has been inside and it looks like mismatched screws all over the place. What a surprise, they're all like this. So I'll just move over here and grab a screwdriver like so. And just like this, I will start removing all of these. And when I get all the screws out, I'll be right back. All the screws have been removed on the access panel here, aside from these two. And the reason that I've left these two in here is I want to show you something that not a whole lot of people know about. So you can see how this has got a sharp edge on it right here and a sharp edge right here, but you can see they've cut the edges off here and here. Well, why would they do that? Well, I'll show you why they did that. So I'm going to take one of these screws out and watch what happens to the bottom panel when you let the bottom panel go. Okay, so I'm going to let the bottom panel go. See how it touches that foot there? Doesn't poke the foot and damage the foot. That's why. So then what you do is you put your hand behind here like so, put your screwdriver in here, put pressure down on this so that you don't lose it, and then remove the panel like so. Just put that down, grab the screw, and remove the panel. That's a solid metal. Probably a couple of pounds of metal right there. So looking inside here, so far, I'll take a look up inside. It looks all original. I think we're doing really good. Now we don't know what's under these things yet, but this all doesn't look tampered with at all. So I'll reposition the camera here and we'll take a closer look at the underside. Taking a closer look in the bottom portion of the chassis here, it really does look all original. I don't see any replacement components. If they have replaced anything, they've done a really good job making it look like original, or it was done very close to when this receiver was manufactured. So the common failure points here are these capacitors. So there's multiple capacitors in each one of these blocks. There's one here, one here, one here, one here. There's a bunch up here. They're all over the place in this thing. So these things are the parts that fail and they drag the supplies down to ground, and then of course things don't work inside here. So these will all have to either get rebuilt or replaced. So I may do either or. These are kind of nice because they act as a terminal tie point and they're also a capacitor all at the same time. So I may rebuild these things. Again, you know, it's a toss-up. What's inside these things a lot of the times isn't very friendly to work with. So I'll cross that bridge when we get there. Same with these in the front here as well. Transformer looks to be in good condition. I don't see anything leaking out of it. There's no tar that's been, you know, hot and coming out of the bottom or anything like that. The reactors look good. Everything seems to look good on the bottom side here at this point. Even all the resistors, I don't even see any burnt resistors or anything like that. So the next thing to do is to bring this thing up and see if it'll even receive. Oh, here's one of the things that tell me that this thing was in some form of a very quiet environment. You can see the line cord here, and you're probably thinking to yourself with this line cord that, you know, this is just a cloth line cord, right? It looks like a cloth line cord, but if you take a closer look here, you see this piece of copper is soldered to it. This is a metal shield. This is like shielding from a coax around the line cord. And they shielded the line cords right up to the wall outlet, and then this was usually run off to another shield that would cover the plug as well to make sure that the oscillator or anything wouldn't radiate out of the line cord and to keep external noise from getting into the receiver. Again, even the line cord itself is metal shielded right up to the outlet. So that is a very, very good sign that this was in a very, very quiet environment. Just before I power the radio receiver up, let's take a quick look at the schematic. We'll also reference the schematic throughout the restoration procedure. In the front end of the radio receiver, you can see we have two RF amplifiers. So the front end is often known as the area closest to the antenna. Okay, so we have the antenna is technically going into this tube here through a tuned stage. it gets amplified, the signal gets amplified, and then it gets put into this stage and it gets amplified again. So we have two stages of RF amplification. What's the benefit of this? Well, of course, we get more amplification for a very weak signal, and we also get the oscillator further away from the antenna by having these tuned stages. So we want to keep the oscillator as far away from the antenna as possible because, again, this is in a very quiet environment. Remember, these things are designed not to be tracked, right? So every heterodyne type radio receiver has an oscillator in it, and what that does is it has a tendency to try to radiate back out the antenna. So by having two tightly tuned stages, because the oscillator is operating at a different frequency than what you're receiving at, because these are so tightly tuned to the signal you're receiving, it really brings this further away from the antenna so you don't get that oscillator leakage running back out. So again, you know, RCA thinking and with two tuned stages here. This is the mixer tube right here. So we have the oscillator and mixer are two separate tubes. We have 3 stages of IF. So most radio receivers usually have 2. This has 3 stages of IF. Again, they're also running these stages very, I guess you could say, moderately. So they're not pushing this radio receiver at all. They want to get the maximum amount of life and dependability out of these tubes. We have the detector and AVC vacuum tube over here. We have a separate noise limiter. We have an audio amplifier and an audio output tube. This is the beat frequency oscillator or BFO section, which allows us to receive single sideband signals or CW. Then I'll show you how to do that when this is restored. We have a rectifier tube here. We have the regulator tube over here. As you can see, this thing is just full of tubes. And this has the added meter circuit. Again, all of these, or many of the CR-88 series did not have a meter in them. So this is showing the additional circuitry for a meter. Again, the CR-88 and the CR-88 are very, very close in their design. Both very, very solid designs. So that's a quick rundown of the schematic. Again, as we're restoring this, I will go through this. And of course, if we need to troubleshoot this when this thing is completely rebuilt, we'll spend lots more time in this schematic as well. Okay, so in order to get this thing hooked up, I need to attach an antenna here. So this is the common, and this is where the signal runs in. And I will use the 2.5 ohm speaker leads. It's completely fine to put a 4 ohm speaker on here or whatever. Don't be worried about that at all. So 2.5 ohms is absolutely fine. If you do put a 4 ohm speaker on there, it just brings the plate impedance of the circuit up to the output tube, and tubes like high impedance anyway, it's not a big deal. And this has the option of 600 ohms and all sorts of stuff in here. So yeah, it's designed to be attached to multiple different setups, I guess you could say. So what I'll do is I'll get the coax hooked up and I'll get the speaker attached. I'll have to attach an external speaker to this, and we'll see if the thing actually comes to life. All right, so I think I have everything set up. I have the volume turned to its max, RF gain to its max. This is the on-off switch. It's on off right now. I have it set to the broadcast band, so we'll just leave it there just for the fun of it, and let's just see what happens. It's just, one moment at a time. So I'm going to turn on the isolation transformer and current limited variac supply back here. It's on current limit, and I'll just have the variac up fully, so I should get some glowing of the bulbs here. So what I'll do is I'll just turn this on here. I'll keep an eye on those. You can see a slight glow at the top there, so when I turn this on, it should get a bit brighter, and it is. So I can see the dial lights are on, and you can see that as well. So we'll just let that sit. Now what I'm going to do is if anything goes wrong, that'll just get really, really bright. Okay, so that's not very bright at all, in fact. So what I'll do is I'll grab a meter here, and let's just see if we have any B+ happening. So I'll turn on the meter here. It's nice because I can kind of keep this where it needs to be. Be there, and what I'm going to do is go over here and see if I have any B+. Put that in there for now. Hopefully you can see that okay. So I'll go right to the rectifier tube here. There's B plus there. So 300 volts or so. So no problems there. Just anything coming out of the speaker. Oh, it is buzzing. Very quietly, but it is buzzing. All right, so there is B plus. What I'm going to do is, it is on transmit rate now. So I'm just gonna let the main filter capacitors, just, I guess you could say, sit with this on it for a little while just to make sure nothing goes wrong. And in a moment, what I'll do is I'll switch it to receive and then we'll move everything over. So I just want to bring things up slowly. Right now it is in current limit mode, so it's not even getting full line voltage. So you can see with basically with the B plus open, it's at 300, which is very conservative for a receiver like this. So I'm sure when I, click it into the receive mode, that's going to drop way down. There's quite a bit of drop across the rectifiers, these 5Y3s. So what I'm going to do is let this sit for just a moment, and then I'll flip that into through. So right now it's in current limit. That little switch that you see right here is down. So that's in current limit. So if I flip that up, it'll bypass this out, and then we'll get full B plus here. I'll make sure I do that with the receive on, so that way it keeps the high voltage down. The radio receiver has been on for quite some time now, and I just recently tested the B plus. It's still there, no problems whatsoever. So at this point, I'm ready to flip the switch from transmit to receive. Now I should clarify, there is no transmit in this, or no transmit capabilities in this radio receiver. The reason that you have a transmit portion on the switch here is way back in the day, the receiver and the transmitter were two separate devices. So if you were going to go into transmit mode, say you were going to start to talk, what you would do is you would flip the switch to transmit, and it shuts down portions of the radio receiver so that the microphone on the transmitter doesn't hear the speaker and you don't get squealing like this. And it also moves the antenna over, and it does that sort of a function as well. Sometimes even on the transmitters, when you were to do push to talk or flip the transmitter on, it would sometimes switch the antenna over. It just depends on how you have it all set up. So when you see transmit or sometimes send on a radio receiver like this, it doesn't mean that it has any transmitting capabilities. It just means that you're basically shutting down a portion of the radio receiver so that you don't get feedback. All right. So I'm ready to see if this thing receives at this point. So everything looks good. I think what I'm going to do is turn the volume down just to be safe, just in case it, is really active. And looking at everything else is looking okay. I'm at the top end of the broadcast band in this position here, so I guess I should probably go down right into the broadcast band. And all right, so I'll flip this over to receive. And what I'll do is I'll flip bypass over here through, and we'll see what happens. So here we go. All right, so now there's full line voltage on here, but let's see what happens. So it's coming to life.
Keep going an entire year.
And in December.
It's trying to receive.
Said it was parents in Mexico.
Oh, and it sounds like it stops here. Yes, there's nothing there. So the oscillator's stopping, possibly shorting plates in the tuning capacitor or weak tube, something like that. This is the antenna adjust. So this peaks up the sensitivity. Basically what you're doing is you're adjusting the antenna. You're peaking things up. So tuning it, I guess you could say. So turn it down. Ooh, that is loud. Oh, and it comes back to life up here. So there's a good chance that, yeah, shorting plates in the, turn that down, shorting plates in the tuning capacitor, possibly a bad connection or a weak tube is what that would be. So let's turn this up, go to this band here, and there is nothing there either. So turn that down, go to the next one. Oh, there's something there. So that kind of tells me that the plates may not be shorted. That sounds like it could be a bad tube. because we haven't moved the main tuning capacitor, so we went from a dead portion to this, maybe even a dirty band switch. Yeah, possibly dirty band switch or yeah, bad tube. So it's one of them anyways. Yeah, it's just there's nothing there. So let's try the next one up. I'll just turn this down. Next one up here. Yep. And nothing there again. So yeah, it definitely does have issues. And it's quiet up there as well. So kind of works on one band, maybe two a little bit, and portions of the entire dial are just not working. So definitely does have a lot of issues. So that's what we're going to be up against. We'll break this down and basically take the thing completely apart and get into the restoration and make this thing perform the way it did when it rolled off the factory line, like I said. So this should be very exciting. Thanks for stopping by the lab today. Hope you enjoyed part 1 of this restoration project. If you are enjoying this, you can let me know by giving me a big thumbs up and hang around. Don't forget to hit the subscribe button and tap the bell symbol as well if you want to be notified as soon as I post a brand new video. I have many more radio receivers coming in the very near future. This is just another one in the lineup. So lots and lots of amateur radio and communications receivers coming, along with all sorts of restorations and repairs sprinkled in the middle. And I will also have the Q&A episodes going between these. So there's lots of stuff coming here. Very, very busy at Mr. Carlson's lab. If you're interested in taking your electronics knowledge to the next level and learning electronics in a very different and effective way, and gaining access to many of my personal electronic inventions and designs, many of which you will see during this restoration project, don't forget to check out my Patreon page. I'll put the link just below the video's description under the Show More tab, and I'll also pin the link at the top of the comments section. So if you click on the link, it'll take you directly there. All right, until next time, take care. Bye for now.